Hello, class. Today we'll be talking about 8.7, and we'll be talking about polar equations and graphs. So we're looking at polar coordinate system. We'll look at graphs of polar equations. We're going to do convergence from polar to rectangular, and then we'll use classification of polar ex equations. So the first thing we want to look at is polar coordinate system. So the coordinate system is based on a point called the pole and a ray called the polar axis. As you see here, we have the pole, and then we have what? The polar axis. So if you notice, when we have the point, it's called the pole, and the ray is called the polar axis. So as you know, we're going to be using these different things. Now, before we was talking about the initial and terminal side. Now we're talking we classifying these as what? Pole and polar axis. So point P has a rectangular coordinates xy. Point P can also be located by giving the directed angle theta from the positive x-axis to ray OP and the directed distance r from the pole point P. So when we look at this, we got what? The polar coordinates of point P are r theta. So if we look at the polar coordinates of point P, so remember rectangular is when we use this is rectangular and this is polar. All right. So make sure you understand what you're actually doing. When we talk about rectangle, we talk about x and y. When we talk about polar, we're talking about r and theta. So let's look. So if r is greater than 0, then point P lies on the terminal side of theta. If r is less than if r is less than 0, then the point P lies on the ray pointing the opposite direction of the terminal side of theta, a distance of absolute value of r from the pole. So we're talking about here and here. So we got one going this direction, we have one going this direction. So keep in mind. So, like I said, and the key things is r is greater than 0 and if r is what? Less than 0. So keep that in mind. So let's look at this. If a point has a rectangular coordinates xy and a polar coordinate r theta, then these coordinates are related to as follows. So we have x is equal to r times the cosine of theta, y is equal to r times the sine of theta. Then we have r squared is equal to x squared plus y squared. Then we have tangent of theta is equal to y over x if x is not equal to 0. Now, we've seen this in the last section. So we're going to still be using the same cases, but we're going to look at mostly graphing and solving for certain things. So let's look at it. So for our first example, they give us point what? 2 and 30 degrees. So if they give us point 2 and 30 degrees, that means that we're starting off what? In polar coordinates. Because they give us the r and they give us what? They give us the degrees. So remember, if you're trying to find the x coordinate, we have what? X is equal to r times the cosine of theta. So we have x is equal to 2 times the cosine of 30 degrees. So we have x is just equal to 2 times the square root of 3 over 2, which is just equal to the square root of 3. Now you do the same thing with y. So you have y is equal to r times the sine of theta. So y is equal to 2 times the sine of 30 degrees, which that equals to what? 2 times 1/2, which equals 1. So if we were to write this in, we got P of what? So point P would be the square root of 3 and what? 1. That's in rectangular coordinates. So just understanding what you're actually doing, it really helps. So since if you think about it, since we have now in this case, if we was drawing out the plot for it, since P is positive, P does I mean R since R is positive, what happens? It says if R is greater than 0, then what? The point lies on the terminal side of theta. So we don't have to worry about drawing it onto the other side. It falls on that line, on the terminal side. All right. So let's look at this other one. Now this is Q, point Q, negative 4, 2 pi over 3. So now you notice that this one falls on what? The opposite side. All right. So let's go ahead and solve for x and solve for y. So x is just equal to r, which is what? Negative 4 times the cosine of 2 pi over 3. All right. So we have x is equal to negative 4 times what? Negative 1/2. So that'll give you what? 2. So x is just equal to 2. So if we're looking for y is just equal to negative 4 times the sine of 2 pi over 3. So y is just equal to negative 4 times the square root of 3 over 2. So y is just equal to what? 2, negative 2 times the square root of 3. So I'm going to put it in a different color so we can make sure we can differentiate. So it'll give me what? 2, negative 2 times the square root of 3. Mm-hmm. So if you look at them, you notice that they're into what? You have two different ones. So this one's going to be on the opposite side of the terminal side because r is less than 0. So this one r is less than 0, and this one r is greater than 0. So this one is so keep in mind what the rules tell you to do. All right, let's look at this. So it says give 3 other pairs of polar coordinates for point P 140 degrees. So let's look at something. So the first thing we want to do, draw this out. All right. So looking at what we got, we know this is the y-axis, this is the x-axis. So I'm going to change. Now, we know that we have something like this. And let's just say that this is point P. All right, which is 3 and 140 degrees. So we know our first thing is 840 degrees. So this is 140 degrees. Now, we have to pay attention to what we have. All right. So let's look at what else we got. So we also have another one that is 3. So if we came the other direction, this right here is negative 220 degrees. That's keeping, so these two, so we have P of 3, 140, and then we have P of 3 and negative 220. All right? So let's look. Then we have one that goes all the way. So we have this one. Then let's say if we had the negative. Let's see if we had, let me find a good color. I'm going to do this orange color. Let's see if we had the negative. So we still have to find P, negative 3, because that's the opposite. Let me erase that. So we can first find it from this side. So it would go from here to here. And let me rewrite that one. And I'm going to start from here. So from here to here. And then that's roughly about what? So we have from here to here. We'll make this negative 40 degrees. So we have one that's negative 40. Now we also have what? If we went around and came around, we have one on this side too, which is what? P of negative 3, and it'd be what? 320. So if you look at what we did was, we got it coming from both directions for the positive P, or for the positive R. Then for the negative R, we have it coming around the other direction, from both directions. So just keep in mind what you're doing. And if you watch the video, you see exactly which direction as I went. So make sure if you have any questions, and these are all your different ones. So it says it gives 3 others. You know, it's plenty more if you're going around and around, but it just wanted 3 more than what we already had. So it gave you the first point and wanted you to go around and find the other ones. All right. If you have any questions, make sure you send me a message through Microsoft Teams or send me an email. So let's look at this one. It says determine 2 pairs of polar coordinates for the point of the rectangular coordinates. So let's look at it. So we got negative 1, 1. So it's saying that the point lies on negative 1 and 1. So we know that that's in quadrant what? 2. Right? Because we got x is being negative, positive, y is positive. So let's look at what we have. So the first thing we want to look at is, let's find r. So r is equal to the square root of 1 squared plus 1 squared. And that'll just give me the square root of 2, right? Easy. Now, remember, if we do the tangent of theta, it's equal to what? Y over x, so we got 1 over -1, which is equal to -1. Now, the same thing, we have to do what? Theta is equal to the tan inverse of -1. And theta should give you roughly 135 degrees. 135 degrees. All right. So let's look at something. It says find 2 pairs, right? So if we look at this, we can look at this from a couple ways. Let's say we have point -1, 1. So this is -1, 1. All right. Now, let's look at where this could go, right? So we say that this is on 135. So I'm going to write a red line going this direction. So from here, all right. So this is 135. And like I said, that this can be written a couple of ways. Now, let's say if we went to the negative spot or going downward. And I'm going to use a different color. Let's say we went from that direction and we went here. All right, what would that be? This right here is 135 degrees. And let's say if we went here, what degrees would that be? If that's 135 up here, that means the reference angle here is what? 45. So the reference angle right here would be 45. So 360, right? So it'd be 360 degrees minus 45 degrees, which would give me what? 315 degrees. So this is 315 degrees. So, the first thing we would write for our first point would be what? The square root of 2. And then that would be what? 135. Because that's what we found from the get-go. Now, the second one, since we're on the what? Opposite direction, it'll be negative square root of 2. And then it'll be what? 315 degrees. All right? Because we're on the what? The opposite. We're not on the terminal side. We're on the opposite of the terminal side. So keep that in mind. And also, you just want to keep in mind that since we're on the opposite side, that the R is negative. So it changes sign from when it's on the opposite side of the terminal side. Make sure if you have any questions about this, you email me so that I can help you with this stuff. If you have any questions, let me know and just email me and hit me up on Microsoft Teams.